Okay. So today, we are going to study today impulse momentum principle, which is nothing but the last topic of the kinetics of particles. So in this, first we are going to study what do you mean by the impulse. Then we will be studying with what do you mean by the impulse momentum, and then we will apply the impulse momentum principle related to the bodies which are subjected to the impact. So let us proceed. So the learning outcome of the today's lecture will be at the end of the lecture you will be able to apply the impulse momentum principle to the bodies which are getting impact. Okay. So let us discuss what do you mean by the impulse. So in this case we can see here object is there and this object is impacted by certain force F, right? And what is the nature of the force in this case? We're considering the nature of the force in this case is force is said to be constant, right? And one more type of force can be acted on a body. First case is this is let us say case one, right? In which the constant force is acting over a period of time. Let us consider the case two, in which the intensity of the force is getting increased, right? And now what do you mean by the force of impulse? So the force of impulse is said to be when the particle acted on a particle when the magnitude of this impulse is the product of the force and the time period on which it acts. So in this case, for force to be impulse, generally the force is considered to be constant. Force in this case is constant. Okay. So now let us consider if the force is variable, then what is going to happen? So for this case, the impulse will be force multiplied by the t whenever the force is constant. And for this case, if the force is variable, then what is the impulse which is acting, let us say, between the time interval t1 to t2? So in this case, impulse will be equals to integration of f of dt. Now, in this case, the time varies from t1 to t2. So, in this case, we find out the impulse, which is nothing but because of the variable force whenever the time varies from the time interval of t1 to t2, right? So, the impulse will act whenever the variable force is between the time interval t1 to t2. Now, as we can say that force is a vector quantity, right? So impulse will be also a vector quantity, right? And what is the unit in this case? Unit in this case is Newton second, because the unit of force will be Newton and unit of the time will be seconds. Okay. Now let us understand what is the impulse force. So impulse force is nothing but a very large force when acts for a very small time and which causes a considerable change in the particle's momentum is called as a impulsive force. So when the impulsive force will act on an object, let us take an example. If a moving particle collides with another particle, the collision duration is very small, but the particles after collision have different magnitudes of velocities and in some cases even different directions of the velocity, right? Now what will decide what is the velocity which is acquired by the two different objects which are colliding, right? And what is deciding the direction of these velocities is nothing but in which direction the impulse acts, right? So now what is the reason for this? The reason for the different magnitudes of the velocities and the different direction of velocity is nothing but the change in the momentum because of which they acquire. Let us take the another example. So whenever the bat hitting the ball, whenever the ball or balls, the action and the reaction forces at the point of contact are the impulsive forces which impart a new momentum to the ball, right? Also, whenever the children playing with that gun, so whenever the spring loaded toy gun releases the bullet, right? The spring force is an impulsive force in this case. So now, how does the impulsive forces are different from the usual forces? So impulsive forces are different from the usual forces because the impulse generated by the impulsive force is mainly due to the large force value, which acts for a very small time. But whereas in actual practice or the usual forces also generate an impulse, but the time parameter is usually a large in general case, whereas in impulse, the time factor is very small. And usually, what is the impulse? The large force is nothing but, in this case, is considered to be important. Now, let us understand what do you mean by the impulse momentum equation. So, if we see the Newton's second law of motion, we have summation of F is equals to ma. Now, for this, if we consider this a is the rate of change of velocity with respect to time, now the same equation can be rewritten it as summation f is equals to m into dv by dt, right? And if we consider that there is no change in the mass as m is said to be constant, so we can take this m inside the differential sign. So now this equation can be rewritten it as summation f is equals to rate of change of mass multiplied by velocity with respect to the time as a differential. Now, if we take this differential time in multiplication with the summation f, so what we are going to get? We are going to get it as summation f dt is equals to d into mv. So this we get. Now, let us consider the next case. Now, if we have to find out what is the change in the impulse, then how we are going to find out? So let us integrate it between the time interval t1 to t2, during which the velocity of a particles during which the velocity of particle changes
during
from
which the velocity of particle changes from
v1 to v2. Okay. I think I have not shared the screen and nobody asked me. Okay. So in this case, we were discussing about the impulse. So this was the first case we have discussed in which the force was constant, and this was the second case that we have considered whenever the variable force is acting from the time interval t1 to t2, right? When the impulse is acted on an object. So we were discussing about the impulse momentum principle in which is nothing but derived from the Newton's second law of motion, in which summation f is equals to ma and a is replaced by the dv by dt. M is said to be constant. So we rewritten this equation. Then summation in f is multiplied by the dt, that will be equals to dmv, which is nothing but differential of mass into velocity. Let us integrate it between the time interval t1 to t2, during which the velocity of particle changes from v1 to v2. So we obtain integration of t1 to t2 for the summation f dt, whereas during the same time interval, the velocity of the particle will change from v1 to v2. So for this, we write down dmv integration varies from v1 to v2. After taking the integration, what we are going to get? We will get here as m into v square by 2, right? and then what we can write it down in this case, this will be replaced by V2 square and not V2, but in this case we will get here as it is a just a differential of V, so we get only the V. Integration varies from V1 to V2. So we will get here M is nothing but a constant. So we will get here V2 by V2 minus V1. This equation we are going to get, right? And then we transfer this MV2 minus MV1 on the left side, where on the left side we have this integration varies from T1 to T2 for the impulsive force. So final expression we get it like this, right? MV1 plus integration of T1 to T2 summation FTT, and finally we have the right side as MV2. So if we write down the impulse in this format, MV1 plus impulse between the two time instances, that is between 1 to 2. So what we can get? So we get MV1 plus impulse between the two, we can say sections 1 to 2 equals to MV2. And this equation is nothing but known as impulse momentum equation. And this equation gives rise to a particle of impulse momentum, which may be stated as for a particle or a system of particles acted upon by forces during a time interval, the total impulse acting on the system is equals to the difference between the final momentum, this is nothing but a final momentum, and the initial momentum during that period, right? So now the question is where we can apply this impulse momentum equation. So impulse momentum is the third equation after the work energy principle, and prior to that we studied about the Newton's second law of motion for the analysis of the kinetics of particles. So what are the different parameters which are involved in the impulse momentum equation? We can see that force is a parameter, mass is a parameter, velocity is a parameter, and the time is another parameter. So thus velocity of particle at the new position can be found out once we know the forces which are acting on the particle and for the time duration for which these forces will act. Also, if we know the initial and final velocity of the particle, then and the duration for which the particle is in motion, we can determine. And why we have to use this method, impulse momentum principle or a impulse momentum equation? As in this, we do not need to calculate the acceleration, right? Which many times use the kinematics relations. So this will give the direct results. Further, we can say that the conservation of momentum equations from the impulse momentum equation can be applied to the system of particles where the momentum is conserved. And now we can apply this to draw the three figures which will show the left hand figure that will show the initial momentum vector, then the central figure that will show the FBD of the particle, and the third figure we will draw is a figure that will show the final momentum of the particles. So by drawing the three figures, we will be able to utilize the impulse momentum equation, and all these equations, all these terms in the equation are vectorial quantities. So we need to follow the proper sign convention for the direction before we put in the NA values. Okay. So now let us solve one numerical based on this. So in this case, a question is given in which we can see that a block of 50 kg is placed on an inclined plane at an angle 30 degree with the horizontal. A horizontal force of 250 Newton acts on the block, tending to move the block down the plane. Determine its velocity. Determine its velocity 4 seconds after starting from the rest. And in this case, coefficient of dynamic or kinetic friction is given as 0.3. So as per the suggested in the application, what we will do, we will draw the three different diagrams, right? The first diagram will be reflecting. The first diagram will be reflecting the initial momentum vector. Second diagram will be reflecting the free body diagram of the particle. And the right hand figure will be showing the final momentum vector of the particle. So let us draw this first diagram. So in this case, it is the initial velocity, which is nothing but zero in this case, right? Because the block is placed on an inclined plane, so obviously its initial velocity will be zero, so initial momentum will also be zero. Now let us consider the equilibrium condition state. Let us take this as y-axis. Let us take this x-axis, and now let us consider the weight of this block, which is nothing but 50 multiplied by 9.81. This is the weight acting in the vertically downward direction. The normal reaction will be always acting perpendicular to the plane on which the object placed. As this plane is inclined at an angle 30 degree, right? So we will show here angle as 30 degree, right? As it is moving, sliding down the plane, so the frictional force will be acting opposite to it, and in this case, what it will be? It will be zero point 0.3 multiplied by the n is nothing but obtained as F is equals to mu k into n, right? And in this case, mu k is given as 0.3, right? Now, what is the force acting on the block? A horizontal force of 250 Newton is acting on the block, right? Which is shown like this. Now, this initial momentum plus this free body diagram will lead to a final momentum of the figure. So let us show the final figure in this case like this. In this case, what will be the final momentum? It will, let us say, denoted by mv2. So what will be the mv2? As the mass of the object is 50, right? Let us denote the velocity final as v, because initial velocity was 0. Now, if we apply the impulse momentum principle to the block for the first 4 seconds of the its motion. First, let us write down the equation. So what is the equation? Applying the impulse momentum principle, we can write it down. And in which direction we are going to apply? Let us we apply this in the y direction. Y direction is indicated like this, which is in the direction of normal reaction. So we write it down. Basic equation mv1 plus impulse between the positions 1 and 2 equals to mv2. Okay. So now, which are the forces in y direction? Forces in y direction are weight component, which is nothing but 50 into 2.98, right? Then the component of this 250 along the y direction. So this is first. Second is component of 250 Newton, and the third is normal reaction. So these are the three forces which act along the y direction. Normal reaction. Okay. Now, what are the forces that we write it down first? So what is the MV1? MV1 is 0, right? Then we write in down all the forces in the direction. So what we have, we take the component of this along the y direction. So we have this angle in this case is 30°, right? So the component of this 59.81 along this y direction will be acting in the negative y direction. So we take it as minus 50 into 9.81 cos 30. Then component of this 250 acting along the y direction. So that will be 250 into sine 30. So this is 250 into sine 30. Then we write it down the normal reaction, that is n, which is acting all on the positive y-axis. So it is n, right? And as it is, these three forces are acting for the 4 seconds. So we multiply it by the time 4 and we equate it to 0. So from this, what we are obtaining? We are obtaining what is the n value, and in this case will give us the value of 300 Newton. So from this we obtain the value of the normal reaction. Now let us apply the impulse momentum equation in the x direction. Apply impulse momentum principle in x direction. What it will give? So which are the forces will act along the x direction? The component of this, first component of weight component, right? Second is again component of 250 Newton component, and what is a third is nothing but this frictional force, that is zero point 0.3 into n. Okay, so these are the three forces will act along the x direction. So what we will write it down? Again we will apply this principle. So what is the initial momentum? 0. Then we write down what is the impulse. So which are the forces? So component of this 15 to 9.81 along the x direction, that will be along the positive x-axis, which is nothing but downward. So that will be 50 into 9.81 into sine of 30. Then what is the component of 250 along the positive x-axis? So we can see that this will be 250 cos 30, right? And this is 250 sine 30 that we already considered, right? So it will be 250 cos 30. Then the direction of this frictional force is opposing to the direction of x. So here we will consider minus zero point 0.3 into n, right? Again we multiplied by 4, which is nothing but the time period for which the impulse acts. Now in this case, as the particle is moving along the x-axis, the final momentum will not be 0 in this case. Whereas along the y direction, the impulse moment, the final momentum was 0, or the component of the final momentum in the y direction was 0, whereas it will not be 0 in this case. So how much it will be? It will be equals to 50 into v, right? By solving this for v, we get what is the value of v as 29.74 meter per second. So in this way, we can find out what is the velocity of the particle after the 4 seconds. Any question over this? Hello? If no, we can proceed for the next question. Okay. Now let us take the second question. So in this case, a 630 gram cricket ball strikes the bat with a speed of 108 kilometer per hour and is hit back by the batsman with a speed of 144 kilometer per hour. Now, in this case, the ball is getting striking the bat with this speed and it is hit back by the batsman with this speed. Both are given in the kilometer per hour. We needed to convert into the meter per second later on. Now, if the ball was in contact with the bat for this much millisecond, that is 72 milliseconds, what we need to determine? What was the average impulsive force exerted on the ball? Now, in this case, let us apply the impulse momentum principles in the x direction to the ball just as it hits the bat and rebounds back during the 72 milliseconds contact period. And let R be the impulsive force which will be received by the ball. Okay. So we draw the three different figures. First is nothing but the ball is moving with the certain initial velocity, right? So in this case, the ball is with the mass 0.63 kg multiplied by the conversion of this 108 kilometer per hour into meter per second. So 108 into 5 by 18. So that will give us 30 meter per second. Similarly, we need to convert this 144 also into the meter per second. So this 144 into 5 by 18, that will give us 40 meter per second. Okay. And this 72 milliseconds also needed to be converted into the seconds. So we divide it by 1000. So that will be 0.072 seconds. Now let us rewrite this first figure. Velocity will be mv1. So v1 is in this case 30. So this is nothing but the initial momentum that will be acting on the object, that is the ball in this case. Now let us take the free body diagram of the ball. So this ball is just before getting hit by the bat. So the weight of the ball is acting in the downward direction like this. It is getting impacted by the bat. So the reaction in this case will be opposing to it. So let us call this reaction as R. And what will be the final momentum? Final momentum will be in direction opposing to the initial momentum because the ball is getting hit back. So let us take this mv2 is equals to mass in this case is 0.63 and what is the velocity in this case? It will be 40. Okay. So now we apply the impulse momentum principle. Applying impulse momentum principle. So we rewrite down the equation mv1 plus impulse between sections 1 and 2, that will be equals to mv2, right? Now what is causing the impulse in this case? In this case, impulse is due to the force R. So what is R in this case, right? So R is nothing but, or what is the impulse? Impulse is nothing but force into T, right? So in this case, force is nothing but R, and what is the time period in our case? It is nothing but 0.072, right? So the force of impulse is in this case is R into 0.072. So unit will be Newton second. So now we apply this mv1. So in our case, mv1 is 0.63 multiplied by the v1, which is nothing but initial velocity, which is 30, plus What is the impulsive force acting on the object? Now we can see that the direction of impulsive force is opposing to the direction of initial momentum. So we need to take it as negative. So R into 0.072, right? And this will be equals to the final momentum. Now again the final momentum is opposing to the initial momentum, and we consider that this x direction is generally positive. So for that we write it down this as 0.63 into 40. Okay, so from this what we are going to get, we are going to get the value of R, that is nothing but the reaction, and this reaction is also nothing but the what is the impulse acting on the object. So that will give the average impulse force acting on the ball. So that will give us 6.612.5 Newton. Okay, so this is how we obtain the value of the impulsive force. Okay, so this was the second numerical we have taken. Now let us proceed for the next. So now let us consider what is the mean by the conservation of the momentum. So when we say that the conservation of momentum will be there, so whenever the initial momentum and the final momentum will be same, right? So what is our basic equation? Basic equation is mv1 plus impulse between 1 to 2 is equals to mv2, right? Now let us consider that the one boat is there. Let us take this a man standing on a boat. So this is a man, and this boat is having MAVA is equals to 0. So what does it means? Initially the boat was stationary or at rest. So VA is equals to 0, and finally it will again reach to rest. So VB is equals to 0. Now what will be the MBVB then? MBVB will be also 0 because the VB is also 0, right? Now if the man jumps off the horizontally in the water like this, so man jumps off into the water. So what will be its velocity? So its velocity is going to be certain something value, right? So man jumps off horizontally into the water with this velocity. What is the velocity with which it is jumping? Let us say VB dash. Now what is going to happen? He induces a backward motion to the boat, and which now starts moving with the velocity of VA dash. Now why this backward motion will be there? Because whenever he is jumping out, he is going to exert certain equal amount of reaction on the boat, because of which the boat is going to move in the backward direction, right? So now if the water resistance is neglected, then how is the motion of the boat is getting induced? So whenever the person or the man gets jumped off the boat, the man exerts an impulsive force through its feet on the surface of the boat, and this induces a reaction impulsive force to the man, which throws him into the water. Since the water resistance is very small, we are neglecting that, and thus what is the impulsive force exerted by the man, which is nothing but the cause of the backward motion. So impulsive force exerted by the man on the boat is nothing but is the reason for the backward motion of the boat. Now let us apply the impulse momentum equation, which also reduces to the conservation of momentum equation. So this is the impulse momentum equation we have written, right? And how does it now converted into the conservation of momentum? That we will write it down. Now let us take the MV1 as a combination of MVA or MAVA plus MBVB. Now what is this MAVA? MAVA is nothing but the mass of the boat. VA is the velocity of the boat. MB is the mass of the person, and VB is the velocity of the person. So this is now rewritten it as like this, plus impulse between 1 to 2, and that we can write it down it as mv2 as MAVA dash, which is nothing but the velocity acquired by the boat after the man jumps out, and MVVB dash, which is also the VB dash is the velocity with which is jumping off, right? Now, what we are going to put here, we are going to put MAVA is equals to MBVB equals to 0 because initial momentum was 0. Consequently, what was the impulse? Impulse between the 1 and 2 will also be 0 because there is no change in the object impulse initially and in the final case. So we write it down this at 0. So what we can write it down here, this completely we have replaced by 0. So we have MAVA dash plus MBVB dash. So we can write it down minus of MAVA dash is equals to MBVB dash, right? So what does it shows? Knowing the masses of A and B and the velocity of the VB dash which it jumps with, we can determine what is the velocity of the boat VA dash. Now why does the negative sign in this case? The negative sign in this case is because the boat moves in a direction opposing to the motion of the man. Boat moves opposite direction to the direction of man. Okay. So in this case, the conservation of momentum takes place in very similar situations, just like whenever the bullet is fired from the gun recoil backwards. Or whenever there is a collision of the two particles, particles move with the different velocity after the collision, on which you might have performed the experiment during the EM lab sessions. Right? Now, let us take the generalized case. So we can say that the dynamic situations involving a system of particles, the net impulse is 0. So we can say that the momentum of the system is conserved. So according to the conservation of momentum, we can say that initial momentum is equals to the final momentum. Okay. Now let us take one numerical based on the this conservation of the conservation of momentum. So let us write down the question. A shell of weight 200 Newton is fired from a cannon from a cannon of weight 12 kilonewton with a velocity of 350 meter per second as shown. Determine recoil velocity of cannon, and we have to neglect the friction in this case. So this is, let us say, a cannon having the gun fired like this at an angle 30 degree, and what is the velocity? 350 meter per second, with which the cannon of weight 12 kilonewton is fired. Now, for such case, we need not to draw the three different objects or three different objects for the initial momentum, free body diagram, and the final momentum. Just the given figure will lead you to the answer. So in this case, we apply the conservation of momentum equation to the system of Cannon. And shell in the x direction, in the direction x. Now let us consider this direction as positive. So now what is the initial momentum of the system before the this gun gets fired? So before the cannon is firing, not there. You can come at 12:30. Come at 12:30. I will meet before the shell was fired. What is the initial momentum? Initial momentum of system was zero, right? And now let us consider what is the conservation of momentum. So in this case, we consider here as initial momentum is equals to final momentum, right? So in our case, as the object was initially at rest, right? Then initial momentum will be zero, right? What will be the final momentum? Final momentum will be result of the mass multiplied by velocity of the cannon plus mass multiplied by velocity of the shell, right? Now in this case, what is the mass of the cannon? Mass of the cannon is nothing but 12 kilonewton divided by the 9.81. So 1200 divided by 9.81 into velocity of cannon plus 200 is nothing but the shell weight. So 200 divided by 9.81 into V shell is nothing but in this case that is the direction of this velocity. It is acting along the x direction. So 350 cos 30. We get it as 50 cos 30. So from this, after solving, we get the cannon velocity as minus of 5.052 meter per second. Now, as we get the negative, so what we are getting? Velocity of cannon is opposing to the direction of the shell movement. So get this as its direction. In this way, we solve this problem based on the impulse momentum principle and based on the conservation of the momentum equation. Okay, so let us stop for now and I will take the uh, continuation of this in the afternoon. Okay, any questions? If you have, you can post in on WhatsApp or send me an email. Thank you. Any questions from your side?